Welcome to the AI Coach by Anil Naso. Today, we're diving into something really core to how modern business is evolving, the way intelligent systems actually talk to each other.
Yeah, fascinating stuff.
As AI gets, woven into everything we do, understanding how these systems communicate isn't just tech talk. It's actually key to scaling up, making better decisions, and boosting productivity.
Absolutely. And our guide for this is a research paper, a survey of protocols for inter-agent communication in multi-agent systems by Sita Kumari and Dr. M.R. Rizvi. It's part of the multi-agent communication, a comprehensive guide from the AI coach.
Right. And our mission today.
Simple, really. We want to pull out the key takeaways, the really important points and lessons from Kumari and Dr. Rizvi, and lay them out clearly for you.
Okay, so let's start at the beginning. Multi-agent systems, MAS. What are we actually talking about here?
Okay, think of it like this. MAS is essentially a team, but a team of autonomous software agents. They interact, work towards goals, but crucially, there's no central controller pulling all the strings.
Autonomous, so they act on their own.
Exactly. Kumari and Dr. Rizvi point out 4 key characteristics.
Ah,
Autonomy, they make their own decisions. Social ability, they can interact. Reactivity, they respond to their environment. And proactiveness, they take initiative.
got it. Like a self-directed digital team. And that social ability part, that's where the communication comes in, presumably. It's not just optional.
Oh, definitely not optional. It's fundamental.
Mm.
The authors really stress this. Communication is how agents sync up, how they delegate tasks, how they, well, cooperate.
Right.
Without good communication protocols, you just have a bunch of agents potentially bumping into each other or working at cross purposes.
Makes total sense. If my team stops talking, things grind to a halt pretty quick. The paper uses Amazon's warehouses as an example. That seems relevant.
It's a great example, yeah.
Yeah.
Imagine thousands of robots moving around, picking, packing. The only way that works without chaos is through really sophisticated inter-agent communication. They're constantly talking, coordinating paths, tasks.
So the protocols are what keep things efficient, avoid collisions, handle order surges.
Exactly. And that coordination, enabled by communication, directly impacts efficiency and delivery speed. That's a real business outcome, something the AI coach often highlights.
Okay, so communication is vital. Now, the paper talks about different types of protocols: interaction, negotiation, coordination. Let's break those down. Interaction first.
Right. Interaction protocols are basically about the rules for exchanging info and triggering actions. A classic example they mention is the contract net protocol, CNP.
Contract net. How does that work?
Imagine an agent, let's call it a manager, has a task. It sends out call for proposals, like an announcement.
Right.
Other agents, the potential contractors, evaluate the task and send back bids if they can do it, maybe specifying cost or time.
Ah, so the manager agent then picks the best bid.
Precisely. It awards the contract. It's very much like a business putting a project out to tender.
Yeah, I can see that. Very useful for assigning tasks dynamically.
Definitely, especially in distributed systems where you need flexibility.
What about the other interaction type mentioned, auction-based protocols?
Similar idea, but more competitive, you could say. Agents bid for tasks or resources. Think about online advertising auctions, or even gig economy platforms where workers bid on jobs.
So agents compete to win the task.
Pretty much. Kumari and Dr. Rizvi mentioned different types, like English auctions where the price goes up or reverse auctions where it goes down. Useful when supplier demand fluctuates a lot.
Okay, that covers interaction. What about negotiation protocols? Sounds more collaborative.
It is, in a way. Negotiation is about reaching agreements that work for everyone involved. So instead of just bidding, agents might exchange offers and counteroffers.
Like haggling?
Sort of, yeah.
Mm.
The goal is to find a compromise autonomously, balancing different preferences or resolving conflicts.
So useful where agents might have conflicting goals but need to find common ground? Supply chains, maybe?
Exactly, like agents representing different companies needing to agree on terms. Negotiation protocols help them do that automatically.
And the last category, coordination protocols.
Right. Coordination is all about ensuring agents work together smoothly, especially on tasks that depend on each other. It's about avoiding redundant work, or worse, conflicting actions.
How do they achieve that?
The paper mentions things like joint intention theory, shared plans. Basically, ways for agents to develop a common understanding of the overall goal and their individual roles.
Like a team of robots exploring an area together. They need to coordinate not to cover the same ground.
Perfect example. That kind of synchronized effort is where coordination protocols shine.
Okay, so we have the interaction styles, CNP, auctions, negotiation, coordination. But what are they actually saying? What language do they use?
Ah, yes. The agent communication languages, or ACLs. This is crucial for the messages to actually mean something. Kumari and Dr. Rizvi focus on two main ones, KQML and FIPA-ACL.
KQML first, knowledge, query, and manipulation language. What's the key thing about it?
KQML is one of the earlier ones. It has this layered structure. Communication, message, content. The message layer uses things called performatives like ask, tell, achieve to show the intent of the message.
So it's like saying, I am asking you this or I am telling you this.
Exactly. And it was quite flexible about the actual content format. Didn't force one specific way to represent knowledge.
Okay. And FIPA-ACL, Foundation for Intelligent Physical Agents, sounds more official.
It is generally seen as more robust, more recent. It's heavily based on speech act theory, the idea that saying something is performing an action.
How does that translate into the language?
FIPA-ACL messages have very specific parts. Who sent it, who it's for, the content, but also explicitly the language being used, the shared vocabulary or ontology, and the protocol being followed. It defines over 20 specific communicative acts in form, request, agree, query, and so on.
Seems more rigorous than KQML.
Yes, it puts more emphasis on the meaning, the semantics, and even the agent's mental states, their beliefs and intentions. It aligns better with models of rational agents.
You mentioned ontology, that shared vocabulary. That sounds critical, regardless of the language.
Absolutely critical.
Yeah.
Kumari and Dr. Rizvi really hammer this point home. You need semantics, clear meaning, and ontologies that share dictionary. Otherwise, agents might use the same word but mean different things. Chaos ensues.
Right, like humans misunderstanding jargon.
Exactly. Ontologies prevent that digital miscommunication.
The paper also mentions things like reliability, scalability when designing protocols, standard stuff for any system, but important here too.
Hugely important. Protocols have to be reliable. Messages need to get through accurately. They need to scale work efficiently even with thousands of agents. Interoperability let agents from different developers talk. And fault tolerance, the system shouldn't collapse if one agent fails.
These sound like good principles for, well, any organization, really. Reliability, scalability.
That's a great connection to make, and one the AI coach often emphasizes. The principles are universal. Designing good agent communication has lessons for designing good human collaboration, too. Clarity, structure, resilience.
Interesting. So what are the big challenges left? Where is this field heading?
Well, the paper points out that dealing with really complex dynamic environments is still tough. Making decisions in real time, super fast. And security, of course. Ensuring communication is secure and trustworthy.
And the future.
The author suggests more adaptive protocols, ones that can learn and adjust, making collaboration more robust, especially when things are unpredictable.
So it's still evolving. This research, highlighted by the AI coach, gives a really solid grounding, though. It really shows why understanding these communication nuts and bolts is so important if you're looking to use AI strategically.
Definitely. Kumari and Dr. Rizvi's work provides that foundation. If you want to implement AI solutions effectively, you need to grasp how these digital agents actually work together.
And, as we said, the lessons learned might even give you fresh ideas for improving how your human teams collaborate. Right. So for you listening, the big takeaway here is that understanding how agents communicate isn't just for the techies. It's fundamental to getting the most out of AI and automation. The way these digital systems coordinate holds real lessons for efficiency and planning in any context.
Yeah, think about it. If we can get autonomous software agents to communicate effectively to achieve complex goals, what can we learn from those designs to make our own human interactions, our team collaborations, even better?
That's a really interesting thought to leave with. Effective communication. It really is the foundation, whether it's code or people.
Absolutely. And the potential for learning between these two worlds, AI interaction and human interaction, is, I think, really exciting.
Thank you for joining us today. Buy the book at the AI Coach website for more business insights.